Who could ever forget this thrill ride when a destructive tornado roared through the grounds at Sun and Fun 2011 out of the blue? Now you have to ask yourself, what's the likelihood of that happening again? Well, why take the chance? Hello everyone, this is Paul Bertorelli reporting for AVweb and Aviation Consumer. In this brief video we're going to take a look at 3 tie-down systems, and we're going to give them the old tug here with our engine hoist system and measure it with our dynamometer. The 3 systems we're going to examine are one called the, I guess, the jar system. We saw this in the jars booth. It's basically a homebrew system that consists of nothing more than a 3/4 inch steel rod with a T welded to the top. You can use this as a single pin, or you can arrange it in a triangular shape to get more soil resistance and connect it with chains. This system is called Abe's tie-down system. It comes from a company out west. It's a kind of a clever take on the problem of tie-down. It's got a stainless steel plate that's perforated, and then you drive this into the ground and put a couple of stakes in it. Then you connect these with a cable and then connect your tie-down to that. So it uses a lot of soil resistance to provide pulling resistance. This is called the Storm Force tie-down. It's nothing but a simple angle iron. It's got holes drilled in it, and then you drive these spikes in through the holes in a kind of a triangular pattern to get soil resistance that way. Now, speaking of soil, you kind of have to take what you get when you go to a tie-down area. The soil might be sandy, it might be wet, you just have no control over it. But all of these will be tested in the same soil, so we ought to be apples to apples here. We'll start with the jar system. Now, the thing about the steel pin is that you can use it in 2 ways. You can use it as a single pin, or you can use it in a 3-pin pattern. We'll test that next. But in a single pin, you need to drive it at about 45 degrees so that the pull on the pin is about perpendicular to the tie-down. So you've seen how the single pin method works. Now we've arranged it in the 3-pin method, and if you do that, you arrange them in this triangular shape here, and then you connect them with a chain or cables or whatever you happen to have. But it's important that if you use the 3-pin method that your load pulls vertically, and that distributes the load between all 3 pins and gives you the most soil resistance. So we'll take a look at how this one pulls. Now, I did a couple of tests with this, and they all performed about the same, which is one of the pins pulled out. You can see that happening. And these will resist about 300 pounds in this soil and this design. You can see that I broke off my crappy welds driving them in. 2 things: if the pins were a bit longer, say 24 inches, and you had better soil and spread them out a little bit further, they'd probably work better. But about 300 pounds in really bad soil, which this is. Okay, on to the Storm Force, and like other tie-downs, Storm Force wants you to position the anchor so that it's 45 degrees from the tie-down, and that gives you basically a 45-degree pull on the load. And these pins go into the hole, so we'll drive those in. As you can see, the Storm Force tie-down has the same problem that other tie-downs do, in that it pulls out of weak soil, and as I mentioned, this is weak soil, even though it's dry. It's got about 350 pounds of force on the Storm Force, which makes it about comparable to the steel pins we tried before. In fairness, Storm Force claims much higher resistance values, and with some effort, we found soil that would support this claim of about 700 pounds of resistance. But in weak soil, it's no better than any of the other products. Next up is the Abe system, which, as you can see, is a little bit more complicated and more sophisticated than the other 2 systems. Basic idea is these 2 stainless steel perforated plates which you drive into the ground. The orientation of these is important. These have to be oriented 45 degrees to the line of the pull, so the tie-down is in that direction, and these plates are positioned just off the end of the wing and a little bit forward. And you drive them in so that they're about 15 degrees angled back. Then these 2 plates are connected with this cable, and your tie-down hooks up to the cable through this little pulley, which provides a little bit of load distribution. Well, I ran out of pull on the engine hoist, so I've had to resort to the tie-down test equivalent of nuclear weapons here. I've tied the anchors to the truck through the dynamometer, and we're going to see what kind of pull these anchors will resist. Well, finally at about 1,000 pounds, the anchors started to pull, but by then the truck's wheels were spinning, so there's no way I was going to pull these out. So I don't really know what they'll do, probably 1,500 pounds. But in any case, I think it's safe to say that AVs wins this contest. If I've learned anything in testing products for aviation consumers, that you get what you pay for, and that's definitely true in these tie-downs. Now, the AVE system is absolutely the hands-down winner. It took more than 1,000 pounds of pull force to even budge the plates. It's also the most expensive. You can buy it in several configurations. You can buy a single plate version, which is a single plate for each tie down, plus the rope and cabling, for about $150. If you want more pull resistance, which is what we tested here, go for the deluxe system, which has 2 plates per tie down, plus the cabling and all the rest of the hardware, and that costs about $212. For the Storm Force, you get 3 tie-down points, the angle irons, you get the rope, and you get all the pins, a case, and a hammer for about $109. Now, if you'd like to build your own with the steel pin system, you can do that. This is 3/4 inch steel pin, or you can use rebar. I do suggest that you take it to a good welding shop, because my welds weren't very good and they cracked when I was pounding the stakes in. So with good welds there, these things will be very durable, and they work reasonably well. You can find a full report on this in the July 2011 issue of Aviation Consumer. For Aviation Consumer and AVweb, I'm Paul Bertorelli. Thanks for watching.